Okay, today we're going to run a Barbier type reaction. It's similar to a Grignard reaction, except we can run this one in an aqueous solvent. And it all happens in one step. So to do this, we have 0.16 grams of zinc powder, and we're going to add that into our microscale round bottom flask with the stir bar. To that, we are going to add 2 milliliters of saturated ammonium chloride solution. Then we will add 1 milliliter of tetrahydrofuran and 0.2 milliliters of our benzaldehyde that we made previously. Once we have that all together, we will add in 0.2 milliliters dropwise of allyl bromide, and that will attack the carbonyl on the benzaldehyde and add to it. So I'm going to get all of this into the flask, including the solvents here, and then we'll come right back. So I've added the THF, the zinc powder, and the ammonium chloride solution to that, and now I'm going to add in the benzaldehyde solution that would probably store it in a flask like this. So we'll get it out here, and we want to add 0.2 milliliters, and I'm going to use a glass pipette, a long stem glass pipette. And if we fill it up to right about there, that's 0.2 milliliters. And I'm just going to add it in through the top of our condenser, like so. So we get the benzaldehyde added in quickly. And I'll go ahead and recap this. Now we want to operate in the fume hood because the allyl bromide is smelly, and it's not a good smell. This benzaldehyde is a good smell, but the allyl bromide is not. I'm going to grab a new pipette so that I do not contaminate our allyl bromide. And I want 0.2 of this, so I'm going to use the same technique, glass pipette. I'm going to fill it up to about there and then add that in, but I'm going to add this dropwise, so I need to add this slowly. So one thing that I've done before is just keep the pipette right here, and then every so often I'll just add a drop in. And I want to do this over a few minutes. So now that we've added our benzaldehyde and allyl bromide in, we need to let this stir for 30 minutes. And after that, we'll come back and finish up the experiment. Alright, well, it's been half an hour, and so we've let our reaction stop stirring. And at this point, we need to separate it from the solids. So to do that, we have a filter, and I've got a little bit of glass wool that I will use as the filter. So just kind of push that down in here, and then we will filter our product mixture. make sure that we get all of our product, we are going to add 2 milliliters of diethyl ether into this flask and then filter that. Now, this doesn't have to be that precise on how much ether we use, but got about 2 milliliters here. Kind of want to keep doing this in the fume hood because the ether and everything is not the best smelling compound. Alright, we'll let this filter, and once we have it filtered, we're going to put it into a centrifuge tube. Now transferred the product mixture into the centrifuge tube, and we're going to pipette away the aqueous layer, which should be on the bottom, and then we will put the aqueous layer back in and do another extraction on it. Go ahead and transfer the top layer, which should be the organic layer, into a beaker. Next, I will pour the aqueous layer back into the centrifuge tube. And then add another 2 milliliters of diethyl ether into the centrifuge tube. Agitate this tube, and then again remove the water layer from it, keeping the organic. Alright, so I've combined the top layers in this beaker, and I'm going to add a little drying agent to it, just to make sure we don't have any water in there. Don't want too much drying agent. And I'll swirl this around, and I'm going to transfer it into a new beaker, and then dry it down from there. So I'm just pouring it away from the drying agent. Sure I get it all. I rinsed it with just a little bit of diethyl ether there. And now I'm going to put it under a stream of compressed air to dry the, remove the solvent. Now the ethers and the other solvents that we've used here have a relatively low boiling point, whereas our product is very high boiling point, and so we're unlikely to evaporate the product. So we're just going to let this go until it appears that all of the solvent has been removed. So after we've evaporated the solvent, we're left with a pretty small amount of a clear liquid, and at this point we will want to determine the product yield and measure the IR of this material, and then we'll clean up. Looks like we got 0.51 grams of product. All right, we can see how we have an OH peak right here, and you can also see how we got rid of a carbonyl peak that would have been right about here, but we have carbon-carbon double bonds from the benzene ring and also from the double bond that was on the allyl bromide. So we can say that we did in fact make the product.